Well, hello everybody, and thank you for joining us today. I'm Evelyn Kent, and I will be your host. I am a text analytics consultant and a member of the Cognitive Computing Consortium Executive Board. The other two members of the Executive Board will be presenting today. The first is Sue Feldman. She's the CEO of Synthexis, where she advises vendors, researchers, and buyers of cognitive computing search and text analytics products. Sue's been an industry influencer for more than 2 decades and founded IDC's text analytics and search practice. She brings all of that experience to the consortium, which co-founded with Hadley Reynolds. Hadley has 35 years in the software industry and currently is the principal analyst at Nextera Research. He analyzes emergent intelligent systems that augment human decision-making. Among other places in his very interesting career, he too has worked at IDC as a senior analyst in search and digital marketplace technologies. Sue and Hadley are going to talk to you about the realities of cognitive computing and how it's being used today. And with that, I'll hand it over to Hadley.
Good morning, and thanks, Evelyn. And good afternoon to some of you. I'm going to get our conversation started today by sharing with you 5 ways of looking at the current state of the cognitive computing market. Where there's confusion and a lot of marketing smoke in the air, having multiple perspectives is a good way to fill in details rather than get carried away by one claim or another. First, I'm going to look at what's happening in the area of mass market advertising. And then we'll look at search query activity on Google. For our third view, we'll check the trend line on the amount and kind of venture funding flowing into the cognitive field. And then, since we're concerned to look beyond the hype around cognitive in this webinar, we'll use Gartner's hype cycle framework somewhat critically to review their ideas on where some of the cognitive computing technologies fall in terms of market expectations. And finally, we'll turn to an anecdotal approach to see what some leading CEOs are telling their shareholders and the press about the field. No one of these perspectives tells the whole story, but taking them all together helps fill in some important insights about the technologies and about the market. So let's look first at what's happening in advertising. At this point in time, the discussion about cognitive computing and mass market advertising has to start and finish with IBM. This slide shows an image that offers a snapshot of IBM's activity. Those of you who are golf fans will recognize this visual as a snapshot from a TV ad run many times during the recent Masters golf tournament in Augusta, Georgia, where IBM is the premium media sponsor. This ad builds on the wordplay accident, retiring Masters champion Tom Watson's name, to humanize a conversation with IBM's Watson machine. Not surprisingly, Machine Watson offers several interesting analytics to golfer Watson about what made him particularly good in certain situations over the course of his career. For those of you ancient enough to have been around when IBM introduced its PC back in the day, this kind of advertising should have a familiar ring. Back then, when virtually no one had even considered having a personal computer in their home, IBM supported their product launch with the biggest computer ad campaign ever seen. And the core of the campaign in the first couple of years was Charlie Chaplin. Virtually every ad featured the little tramp image with a Chaplin lookalike getting up close and personal to this strange 16K machine. The spots were all about humanizing the product. They were about breaking down our instinctive resistance to the new and the unpredictable. Today's Watson ads are ringing the same changes. Instead of Charlie offering a rose to a PC, we have Watson engaging Watson in a civil and intelligent conversation, as if we were all happy talking with some disembodied machine about the details of our careers and our emotional highs and lows. We all may have computers in our homes now, but we still haven't really started inviting computers to be our confidants and guides. IBM is spending at a massive scale, betting that we need to get over it. Google and Facebook have more researchers. Amazon has the most popular product in Alexa. Microsoft has been active with products like Cortana and contributions to open source. But as far as what the general public knows about cognitive, we have to single IBM out as the company that has placed the biggest bet. They've created programs across the broad marketing landscape for cognitive systems, from the Jeopardy Watson pilot to the most expensive TV ad campaigns to partnership programs in multiple specialty fields like genomics and healthcare, and to program seeding educational curricula at universities. So if none of the other technology, many mega brands are using mass advertising, the question naturally arises as to why is IBM going to the expense and trouble of carpet bombing the airwaves with Cognitive? On the next slide, we look at some facts that IBM has shared. In her annual shareholder meeting this year, IBM CEO Jimmy Rometty answered the question by starting to talk about cognitive business as the direction IBM believes its customers will be moving. IBM views the area of cognitive as a core growth area for the company over the next decade, like they did the PC in 1981. IBM has chosen to get out ahead of the trend and develop offerings to help their customers take a next step in big data analytics and cognitive applications. To do so, they've renamed their core strategic market platform from Smarter Planet to Cognitive Business. They're engaged in a 9-figure ad campaign to broadcast this message. So this is not simply a marketing play. It's a bet the company move that IBM can reestablish a growth trajectory by leading this field. We can be sure that IBM's activity alone will keep the term cognitive computing in the media for the next 3 to 5 years at least. But clearly, big media investments by any company do not make a market in and of themselves. So the next place we'll turn to look to gauge real interest in cognitive computing is what John Patel dubbed the global database of intents. That is to say, the search logs at Google. Those of you who use Google Trends will recognize the chart in this slide as standard output from the Google Trends site. We ran 2 terms through Google's engine, artificial intelligence and cognitive computing. As you see from the graph, interest in artificial intelligence, as gauged by search queries related to this phrase, have been essentially flat for the past 5 years. When we look at the trends for the term cognitive computing, however, it's clear that the relative interest in this area has been going up dramatically, particularly over the last 3 years. By the way, if you haven't used Google Trends, it's an interesting way to keep track of what's going on around the web. Just go to google.com/trends. The data Google reports is not simply a count of queries on a term, but it is statistically adjusted to reflect the relative strength of interest in that term relative to all terms in a geographical area. So the results for cognitive computing perhaps indicate that since not many people were familiar with the term prior to 2011, the interest today is that much stronger. While we're talking about these 2 terms, AI and cognitive computing, let me take a quick detour to clarify how we view the very real differences between them. They're often used interchangeably to point to any kind of technology or human-machine interaction that features the computer in anything like an advisory role. But there are also real differences between the 2 when we look at them close up. In the blue side of the brain on the left, the artificial intelligence community is focused on the development of machines as autonomous actors. They are conducting important research to make computers with new architectures that can mimic the human brain. And they expect an AI of the future to become the author of their own interactions. With human beings, the movie Her from 2013 is a required viewing assignment to get a feel for this approach. In the gray side of the brain to the right, cognitive computing, in our view, takes an entirely different approach to the human-machine relationship. Cognitive systems continue the legacy of the machine being dependent on human guidance. They leverage today's technology advances to help humans contend with the digital life and the content, the volumes of content that we're all living with. And the finished product in a cognitive system makes the machine an agent for a person, doing well what people do poorly and freeing up humans for making more informed decisions. Let me continue this detour with a quick survey of the evolution of some of the technologies behind today's cognitive systems. In the early days, during the first AI boom of the 1980s, you needed specialized hardware and software to attempt feats like voice recognition or image recognition, not to mention search and other unstructured data analytics. When these systems couldn't deliver on their promises, AI went into a nuclear winter for a decade or so until the surge of activity on the web after Y2K gave rise to clever site-specific functions like Amazon's recommendation engine that leveraged a lot of that earlier work and incorporated innovations as well. And we see it also in the rise of modern web marketing features like ad targeting and hyper-local alerts. But now, in today's market, we're living through both the first generation of widely available mobile digital assistants and a brand new environment for developers of cognitive applications. In 2015, industry heavyweights got caught up in a race to open source a variety of machine learning APIs, hardware designs, and other support services which are making cognitive system development accessible in unprecedented ways. These changes are helping fuel a surge in new business formations. So we turn now to our third slice through the cognitive market, and that is the analysis of venture financing activity. The first graph of quarterly financing data shows the amount of dollars committed in the blue bars and the actual number of companies funded on the brown line. What we see is both the volume of venture dollars rising significantly in 2014 and 15, as well as the numbers of startups reaching a much higher level during those years than in previous years. And on the next slide, we're going to look a little more closely at some of the granularity behind that data. The chart on the left shows the top 10 venture funds engaged in the field and indicates the number of companies they have committed to funding. The result indicates that once you're in, as the average number of bets is 11 companies per venture group. It's also interesting that among the top 10 investors in cognitive, we see a true mix of firm types. Angel firms like Silicon Valley Angels, incubators like Y Combinator, mainstream venture partnerships like Accel Partners, and even corporate investment funds like Intel Capital, who leads all investors in their interest. And this data does not take into account the $100 million that IBM has committed to investing in cognitive startups. On the right-hand chart, the tall blue bars along the base of the histogram show seed or angel stage companies, which means that the market is still made up of more visions than it is of shipping products. Given a 2 to 5 year time span from idea to shipping product, many of the products that will support cognitive computing in the medium future are not even on the market today. We will be continuing to track the startup scene in the space and offer consortium-created research on what makes a cognitive product successful. Now we turn to a view of the technologies that many of the new startups are founded on. Here we are using one of Gartner's greatest contributions to the technology industry, namely the hype cycle model. This chart shows the most recent Gartner hype cycle publication. And in it, there are 9 component technologies that are highly related to cognitive systems on the chart. As you can see from the red ovals, Gartner considers most of these technologies to be in their very earliest phases of inflated expectations. Gartner considers virtual personal assistants to be at the very earliest of stages, while they see smart advisors, like customer service recommendation systems, for example, as more mature, but still not proving themselves as valuable business tools. Machine learning and natural language question answering are 2 of the 3 most mature technologies, as represented here by Gartner, and both are heading straight down into the disillusionment phase. My feeling is that here Gartner has missed the relative maturity of machine learning and accelerated the maturity of question answering dramatically. Despite the jeopardy playing Watson, open field question answering is still an unproven capability for virtually all applications. But as we've seen, machine learning and its more recent deep learning approaches are increasingly baked into the core of everything from web image search to voice recognition to Alexa commentaries. Overall, like the venture investing data, the hype cycle certainly points to the nascent character of cognitive and a challenge to the field to prove its actual practical value. So we turn now to anecdotal examples of what big technology company CEOs are saying to their shareholders and the press. These are quotes from Google, Microsoft, IBM, and Ssas. In each case, the leaders of these firms are talking about the large opportunities they see in cognitive approaches. They also share a perspective that right now is the beginning of what will be a distinctive new period for enterprise technology firms and their customers alike. All of our looks at the cognitive space reinforce the impression that the market is still in its earliest days, and we are going to turn now to look at in a lot more granular detail at some specific use cases that are beginning to deliver value through cognitive tools. And for that, I turn the session over to my colleague, Susan Feldman.
Thanks, Hadley. First, I should tell you that there's a great deal of detail in the slides to come. Don't try to scribble madly if you're taking notes. The slides will be downloadable from the Cognitive Computing Consortium site. So I may not hit all of the details, or we'd be here all day. However, you'll be able to review them at your leisure. So now let's turn to the uses for cognitive computing that we see in the marketplace today. If we look beyond the hype, there really are no turnkey products yet, but remember that cognitive computing is an evolution, not a revolution, as we said. All of the trends we have seen, big data, natural language interactions, conversational systems, probabilistic computing, artificial intelligence, and above all, contextual computing, have been emerging for quite a while. What's different is that the emphasis on contextual computing that is derived from a highly integrated collection of technologies has become the lens that we use to collect all of the other technologies. What does a person need at this particular time, in this particular task, in this particular location, in order to go on with whatever it is that he's doing with the best possible evidence to support him. These new applications then address problems that the products on the market today cannot. So if you look at this next slide, you'll see an array of attributes that we use, no, last slide please, that we use to classify cognitive computing use cases. Our research today is focused on understanding the spectrum of uses to which cognitive computing might be put, because as you can see, this is kind of a Chinese menu of mix or match. And this deciding which technologies to use, which data to use, which behaviors to use, for what kind of goal is a complex, so far, process. The attributes so far fall into 4 big buckets, and I'm not promising that will be the case once we finish our research. But the 4 buckets are the data sources, the technologies, the behaviors that we want out of the system, and the goal or value that we hope to derive. If I were planning on investing in cognitive computing, I would start with the problem to be solved and then work backwards from the right side of this slide to determine what's the value. What kinds of behavior would we like to see in terms of output and interaction? And only then would I consider which technologies are required to fit those requirements, and then, of course, determine which underlying data sources are necessary and how to knit them all together. And each one of those topics would actually require an entire presentation on its own. So let's move on to some examples to illustrate how we use these variables. This first example is already on the market. It's a cognitive oncology assistant for doctors. And you have undoubtedly heard that healthcare is one of the top early uses for cognitive computing. There are a number of reasons for this. First of all, good, reliable data sources exist that are already well curated and well structured. There's also an overwhelming set of ROI metrics, from cost savings for insurers to making better decisions that may mean life or death for patients. We see the move to electronic medical records that is government mandated as another driver for trying to develop some of these advanced applications. And then finally, of course, the fact that there's too much good information, let alone all the questionable information, in other words, big data, so that no physician can possibly keep up on his field entirely. So that means that we need help. These cognitive assistants work with doctors to perform tasks like ingesting all the information from patient records to clinical trials and drug side effects. They use the lens then, having formed this collection, of each individual patient as context, to filter and to rank possible treatments based on factors such as, for instance, the patient's genetic profile, his preferences, his history, and his access to medical care. Once that is done, they match the results with similar cases to determine and recommend best outcomes. But it's part of a dialogue that they set up. They may offer evidence for the recommendations, but in the dialogue between patient, doctor, and cognitive assistant, these can be altered, discussed, changed. It's an evolutionary process in coming up with a diagnosis. Each party brings a unique set of views to this process, of course. In this next slide, corporate banking. Customer Matrix has put together a very interesting use of cognitive computing built on their own platform. This application from Customer Matrix understands business goals. It creates models of successful investments, and then uses the internal social graph, which it has also derived from sources like HR, to find a personal way into a business deal. It uses news sources to identify investment opportunities, as well as HR and Salesforce data, and external company sources to build a graph of who knows whom inside and outside the company, and how they might be related to the investment manager. It's an interesting use of the idea of 6 degrees of separation. Then it ranks the recommendations by how well they fit the business goals of that particular investor. This is what a good investment analyst does, of course. Who mixes the people, the business aspects, and the market knowledge to make guesses on good investments. Providing some help through the complex mix is a persuasive use of cognitive computing because it adds evidence to the hunches, and this is already in use. In this next slide, land lease management, which seems like a rather arcane topic, I've included this because, first of all, parts of it are already deployed, and secondly, because it's an example of an extreme use case. It requires that extreme accuracy be derived from skimpy data. In other words, you get land leases and contracts coming into the system in paper form. They have to be OCR'd, but the OCR has to be extremely accurate. Extracting accurate terms from a single unique legal document is hard stuff. But this application also needs to add data from regulatory agencies, from GIS systems, from internal business strategy plans, from market data, etc. And it has to normalize across these to find patterns and to get reliable recommendations for acquisitions or divestitures. And for some kinds of interactions, it needs to present ownership, for instance, on a map of an area. So in this case, what you see is a query which companies have holdings that are adjacent to ours and leases that expire before 2020. This begs a geographic presentation, a visual map to interact with in order to see this kind of complex ownership pattern very easily. So the system also needs to find specific contracts or specifications within contracts, and as well look at patterns of ownership on a map. It needs to predict best acquisitions for a particular business, and the users need to get alerts on expiring contracts. So it must be both question answering system and provide pattern discovery. And as I said with this query, this is not something you can ask your mother's search engine. Let's move on to the final example, which is a cognitive assistant for the blind. This is visionary. It is in development mode, but it is an example, I think, that shows you how if you throw everything we know at a system, you can come up with something which is, mind-blowing, essentially, which is what I think this is. It's still in the research stage, and its promise is overwhelming. Using pretty much every technology we know, it helps someone who is blind to navigate through a physical location, making them more independent. It starts with a map of a known location, but as the system learns, it begins to make guesses about what is a door, what is a good pathway to walk, what are the obstacles that need to be avoided. It learns to navigate new as well as known areas as it learns more. And in order to do this, it combines things like machine vision, cameras, voice recognition, predictive analytics, machine learning, modeling, natural language interaction, face recognition. The team has also built models of objects and their relationships to actions. So a chair is for sitting, but a door is for walking through, and it has the properties of opening and closing. So if we look then at a screenshot, a series of screenshots that I took from the YouTube video that you'll see the link to on the bottom, what you'll see is the story, the demo, in which a blind person is walking through a door to a canteen. She encounters somebody named Nick. He's smiling, recognizes him, and it tells her who it is and that he's happy. And she can stop and say, "Hi, Nick," which she does. Takes her to the canteen. It says to her, "What do you want to buy?" She says, "Cookies." Takes her to the cookie shelf. She looks using the camera at the barcodes of the various packages. Unfortunately, in the demo, it also tells her that she gained 5 pounds last week, and perhaps she should consider something like celery, I assume. But she goes ahead and buys the cookie and then navigates back. So by all means, take a look at this this video. It's amazing. All right. So what can we learn from these examples? Next slide, please. We're only at the beginning of understanding when it makes sense to move to a cognitive application and when a current generation of software will suffice. Cognitive computing gives a human context to information. That is, it uses the complex mix of who you are, what you are doing, and how you need to act as a lens to filter or organize a complex, changing collection of information. In other words, there are an awful lot of moving pieces. And like any human, this system has to be able to make snap judgments as the changes occur. The result is, as these systems develop, that you should be able to get more relevant answers, predictions, or patterns from the information. But it also means that the output that you receive may differ from what you receive 2 months from now, and certainly what I receive as a different user. To do this, it needs to be contextual. It needs to be interactive. It needs to explore as well as answer. It needs to be probabilistic so that it can shift. There are also, in this next slide, situations in which you don't want to use cognitive computing, or when you don't need to, at least. There are times when predictability is what you want, and in fact, regulations may require that you know how you arrived at the answer that you and everyone else received. Also, there's no sense in investing in a cognitive system if all that you have is numeric information from a small number of sources that are needed to churn out reports on command. At least that's the way we're seeing it today. It could change. So in this next slide, you'll see that the complexity of this kind of system is the name of the game in cognitive computing. There are always trade-offs and choices to make whenever you invest in something, whether it is a new car or a new application. How do you judge what is good enough? And that's in fact what we're going to have to increasingly look at. Not perfection, but good enough. And that's a hard switch. As we have shown, the degree of accuracy required depends on the goals for the application. These are some of the attributes we look at in classifying an application by use. In other words, do you want more serendipity or do you want a high confidence level? How fast do you want the processing? How fast do you need to ingest information? What's the impact of the outcome? How thorough do you need to be? How thorough do you need to analyze? And who's using it for what purpose? All of these are part of the design of a cognitive system, and one person's customer engagement system may not be another's. So this adds to, in the next slide, these challenges to adoption. As we know, with any new tool, the market faces a number of hurdles to leap. In this last section, I'll discuss some of these challenges. First, vendors and also far-seeing technology strategists are waiting for the market to catch up. There is growing coverage in the media, but, as we've pointed out, an awful lot of hype and misinformation. We've seen large demonstrations, and they've certainly attracted attention, like IBM's Watson or Google's self-driving cars or the Amazon Echo, Apple's Siri or Microsoft Cortana. And in fact, I just bought a Cognitoy that's going to hit the market this June because I think it will change the way kids play. It's a learning toy. Sounds like it'll be cool. And you know, your Cognitoy is going to differ from mine because you will be asking it and interacting with it in different ways. So where are we? In this next slide, you see that we have entered the early chaotic era. We've seen eras of profound technology shifts with their attendant innovation, ferment, and confusion before. For instance, consider the shift from horses and carriages to cars and trucks. For a time, both of those shared the road. We had no guidelines for when to use one and when the other, which took priority. Who was responsible for runaway horses when they were frightened by a backfiring motor vehicle? We suddenly needed traffic signals, speed limits, and new rules of the road. We needed standards for what a dashboard looked like, and we needed to understand what equipment we could expect to be standard in a car and what was custom add-on. And that's really where we are today as cognitive computing edges out an earlier digital generation of software, hardware, and services. In the process of this technology shift, industries will be upended, standards will emerge, which is both more comforting and less interesting. And the need for and uses of cognitive systems will become more clear. So aside from the technology, we also, in this next slide, see that social and legal issues need to be resolved as well. Like that earlier era, we can expect widespread disruption, and there are some pretty interesting books that are being written and which will arrive at the end of this month as well on that topic. In fact, it's already happening. We need to address these social and legal issues that new technologies bring, like who is responsible for computer errors in a self-driving car in an accident? Is the programmer? Is the manufacturer of the car? Is the driver who wasn't overriding it? We don't know. Do we want our medical data accessible? If so, by whom? How about, is better shopping enough to let go of privacy control about our habits? And of course, to what extent can and should computers replace humans? So, in conclusion, from an analyst's perspective, this is all profoundly interesting. It's too early to see how each of these challenges plays out, but we know that from a technology perspective, there really is no way of going back. To cope with it all, we hope to develop a central hub for discussing cognitive computing, its issues, its impacts, and We hope also to provide credible guidance and information on its use. So thanks very much, and over to you, Evelyn.
As Sue said, to that end, we really would like to, we'd really like to invite anyone to and everyone to join the consortium. For the first year, we are making that available to everyone without any membership fees. And what we really want to do is bring people together. So collaboration obviously is the goal. We want to bring folks together to share ideas and move forward, really move the industry forward. We also are going to conduct some research which we will make available to folks. And we're hoping to launch a publishing program. We already are doing some publishing. We've got a blog which we encourage you to follow and take a look at. And we are going to have some events so that people can actually meet one another in person. So all of this is to help collaboration and help the field. So we hope that you all will join us. We also have a couple of questions, so before the end, and if you have a question, feel free to send it in, and we'll get started on some of those now before we wrap up around 12:50, I think. So, Hallie and Sue, I think I'm just going to throw these out there and let you all take them as you'd like. So our first question is, what kind of background or experience is important for a job in cognitive computing?
Well, I guess I'll start with that. Obviously, as we have said all along, there are a lot of allied areas and a lot of skill sets that go into making a cognitive system work. So if you have experience, if you have expertise in AI, machine learning, text analytics, software integration, for heaven's sake, natural language processing, conversational systems, user assessments, et cetera, all of these pieces and more go into putting together systems. So we would say that anyone who has expertise in these areas is a candidate for hiring, depending on the application and the use and whether or not you're looking for a job with a vendor, with an enterprise, with a B2C company, because the skill sets will vary.
Alrighty.
I'd like to maybe just expand just a little bit on that, Evelyn, if I could. I think it's important to note, in addition to the, so to speak, hard skills that Sue has just enumerated, it's important to, within a given field, if you're eager in staying in that field or if you're eager in moving to another, there's a tremendous need for subject matter experts to do what used to be called knowledge engineering, to figure out what is of maximum importance to get a particular set of tasks done, or to provide a system that provides certain kinds of insights or support for a human in their business role. So I think it's that's another thing to consider if you're looking at the cognitive area as a possible career direction.
You know, that's true. And Hadley, one of the things I'm seeing is a demand for anthropologists, which is really interesting because, of course, anthropology majors had a lot of trouble finding jobs 20 years ago. But we're already seeing that they're being hired in order to develop systems and frameworks and processes that can then be translated into a cognitive system.
Okay. Shall we move to the next one?
Yeah.
So where do you think cognitive software will make the biggest impact? What fields, I guess?
Well, yeah, let me begin that anyway. I think that even though we talked a lot about enterprise applications today, I think it's fairly clear that, in fact, the biggest impacts are going to be felt initially in consumer areas, and we're more likely to see cognitive kinds of features coming out of Facebook and Google and Amazon than we are on a broad basis from IBM or Microsoft. And so I think in terms of the numbers of people who are impacted, I think the consumer giants are going to be the ones who bring us cognitive things, whether that be, you know, smarter and smarter recommendation engines, or whether it be self-driving cars, or whether it be self-prompting recommendation systems that sit in your living room and tell you what movies you ought to be going to see at the local multiplex. So yeah, I think the biggest impact will be consumer, actually, but perhaps the more lasting and maybe disturbing impacts are probably going to be in the enterprise, where the addition of more intelligent systems are going to have some kind of impact on the professions, what we formerly thought of as the white-collar professions, and the blue-collar ones for that matter. But in particular, intellectual work is going to be changed dramatically, and so that's another area that we're going to be tracking as these systems get more common. So stay tuned on that front.
You know, Hadley, one of the things that happened when search suddenly sprang upon the public consciousness was that it became an expectation from people who were using the public search engines, the consumer search engines, that they would also be able to search within the enterprise or on business sites. So in a sense, what we would expect is that applications like Google Inbox, which already gives you candidate answers when you get a message that you can just click on without having to type, that would help to drive the demand, I would think, for cognitive systems, because we will become impatient with the system not knowing already. For heaven's sake, we just did that. Why can't you know that we have to do the same thing all over again and respond the same way? And Inbox, as I said, is a good example of an early conversational system.
Right. Well, we're seeing a lot of stuff behind the scenes, right? I mean, that's not necessarily visible in the consumer space. Certainly, IBM, Watson, focus on health that might change things that then kind of cascade. And I personally would rather have the one that tells me how to get better as opposed to the one that tells me that I need to eat celery, because you know, I already know that. Just let me have a cookie.
I don't know anybody who craves celery. I'm sorry.
Yes, we know. We wanted to tell us stuff we don't already know, probably. Okay, so a couple more interesting questions. One is kind of on the hardware side, and then we have a really interesting one popped up just now. So what will cognitive computing replace in our IT stack?
Good one. I see it as a layer on top of what we already have for the most part, in which what we have is the legacy systems continuing to ingest and refine information, and then additional capabilities being layered on top. So essentially, the legacy systems turn into systems of record, to perhaps repositories of information that can be tapped, etc. At least for the time being. Obviously, if you're starting from scratch 5 years from now, it's possible that you'll be able to get a software stack that's top to bottom. But right now, there's no reason to replace. I don't think what you're going to do is just add this extra layer on top that knits everything together and uses what you have in very different ways.
Hadley, do you have anything to add?
Well, I guess what I would add is that I think that what we've thought of as the realm of the data warehouse and of business intelligence is going to be impacted by the integration of cognitive into the analytic cycle, so to speak. And I think there's going to be a real uptick in the cadence of analytics. In other words, we're going to get much more real time and much less weekly reports or monthly reports on particular fixed items. Managers will be learning to ask more and more complex questions, which the analytics community can handle, but they may well choose to start creating behaviors, as we pointed out in that sort of schema of cognitive application behaviors. Users may want behaviors that are much more like for example, the consumer systems that Sue was talking about. You know, if you could imagine an Amazon Alexa for your business that would be prompting to you for the fact that it looks like sales are trending down in the Latin American region, and you can hear that, you know, 2 weeks into the month instead of at the 30th day, that's going to have a serious impact on how the whole analytics and data integration story plays out in the enterprise.
Good point.
Okay, so this is a three-part question. Do you consider chatbots to be part of the cognitive computing market? There seems to be a hyper focus on them right now, and is there a specific reason for this prioritization? Two-part.
Good one.
Well, I would start with saying I don't really consider them to be part of the cognitive market, but maybe, you know, I think it's open for debate. It sort of depends on how the actual capabilities of chatbots evolves, because you could certainly see them evolving into interactions that are a lot smarter than they are now. But I think the reason they're important in the market is because they challenge the premier position that search has played ever since, you know, the early 2000s and before, for that matter, in online commerce and online advertising and the way people express their intentions over the internet. So I think that in the long run, there's I think that the search companies are rightly looking at the chatbot, the growth of chatbots as a potential source of competition.
Well,
but
and
I think
also,
they also have.
Go ahead. Well, I was just going to say that
they conclude.
Yeah, go ahead.
I was just going to conclude by saying that they have yet to really prove whether or not, you know, people will take to them the way, you know, Pinterest kind of took over a number of other networks, or whether people will get bored when they prove not to be quite as jazzy as it looked like they would at first blush.
Yeah, and of course they can. It depends on what kind of answers they return, right, and whether it's a real conversation. You know, in terms of chatbots, first of all, they're more engaging than the search box. There's this question about, is that a real person or isn't it a real person? And I know some people who purposely ask off-the-topic questions just to test the chatbot, so they're a little intrigued. But on top of that, the fact is that you can put together a chatbot reasonably easily at this point, and the ROI, either in terms of cost reduction or customer retention or revenue increase, and that's always the case in business. What are the reasons why? Would get businesses interested in investing. So it's edging towards cognitive is what I would say, and what's going on underneath it, whether it's a script or it is, in other words, you're getting repeatable results no matter who asked the question and when and where, or if it is a learning system, that would make a huge difference in how the chatbot appears to the user.
Okay, so I think we've got time for one more question, and that is, sorry, I just lost it. Are there any apps out there that we can take a look at and see how they're actually working in the cognitive space? Do you have any suggestions for applications that we might go look at to see what this is actually how it's like in practice?
Good question. You are going to see some manifestations of this in various healthcare systems already, but it depends on whose healthcare system it is. So I can't point you to, for instance, who is using WellTalk would be a good example, which provides contextual recommendations for individuals within a subscriber base to health insurance. So that's certainly out there. Also, the IBM Bluemix and Watson, various kinds of applications are available freely, and you can put together your own system. It's like a sandbox. You might want to try that. So you might take a look at what IBM has to offer. Certainly, I've messed around, for instance, with their personality insights by dropping the introduction to my book in there to see who they thought I was. It was lots of fun, and I highly recommend it. But you can also use those tools, those analytics, those visualizations, and cobble together your own system. That's probably the biggest opportunity I know of for people to experiment. Hadley, you know of any others?
I think a lot of what we find is YouTube-ware. I mean, the fact that you pointed to the research model of cognitive assistance for the blind coming out of Carnegie Mellon, that would be another area to kind of keep track of the prototypes, because really, as we pointed out during the course of the session, there aren't a lot of shipping applications at this point. In terms of the healthcare, I think Cleveland Clinic is one of the IBM partners that's been working on this the longest. So that would be another. But they don't. A lot of what you might think of as enterprise applications aren't exactly accessible by the general public. But there are, again, on YouTube videos of interviews, so to speak, with some of the users of these systems and their perspectives on what it was like to develop the system and what kinds of goals they're trying to achieve. So I think that's pretty much the state of the market at this point.
Alrighty, so we can wrap up now, but we have one more question. Do y'all want to take it? And folks can drop off if they'd like. Y'all feeling good about that? Too, Hadley? Okay.
Yeah, of course.
So given that you highlight the uncertainty of return on investment for cognitive computing applications, I assume that IBM's 9-figure ad campaign must be matched to an expected ROI. Any insights on this?
I have lots of insights on it. Yeah, I mean, I did early research, a decade ago, looking at the emergence of these kinds of unstructured information applications. We didn't even know it was going to be cognitive computing at the time, and the predictions at that point were pretty big. Hadley, you want to take a look at this too?
Well, this is in terms of the IBM specifics, I think they see their overall, their core enterprise marketing platform as a, very broad campaign that goes across all of their products. So the ROI is not just on cognitive, but it's also on everything else that they're a very difficult time achieving any kind of reasonable growth over the last 6 or 7 years, roughly. And so they need to return to some kind of growth mode. So I think that they see continuing to their brand front and center in the market space, the broader market space, and having a lot of brand awareness as a technology leader, making their customers feel comfortable that IBM is not going to leave them behind. This can be extremely important to them, whether they're selling a mainframe or whether they're selling a API. So I think they're not doing this for the fun of it, that's for sure. But how you, like all advertising, how you put a finger on the exact ROI behind, for example, the Tom Watson spot from Augusta, or the Cleveland Clinic spot, also shown at Augusta, is very difficult. It's not a science.
But Hadley, just to add to this, there is some ROI that we do know about. For instance, Boston Children's Hospital developed a system called Open Pediatrics, and it is already saving children's lives around the world in places like Tierra del Fuego, in which it hooks up who are very knowledgeable with people who can work with them but do not have the experience to carry out the procedures thousands of miles away. So we have, yes, it's anecdotal, but these systems are working, and working in a remarkably life-saving and life-changing way.
Okay, any last remarks before we wrap up?
No, I think that's good.
All right. Thank you, everyone, for attending. We will send this a link to the recording, which we'll post on our website in case you want to go through that, as well as the slides, so that you'll have them for reference. And stay tuned for an ongoing series that we are planning for throughout the year. Thanks so much, everyone, for attending.